seekers, welcome to this special webinar. My guest today is Dr. Larry Farwell. He is the leading forensic neuroscientist in the world. So he's going to tell us all about the brain and about brain fingerprinting. Dr. Larry Farwell was featured in Time magazine in the 100 top innovators, the Picassos or the Einsteins of the 21st century. He is Harvard educated and the inventor of brain fingerprinting. He conducted brain fingerprinting on Stephen Avery, and he's featured in major national and international news, and he's hired by the FBI, CIA, US Navy on high-profile cases and counterterrorism worldwide. I saw you on 60 Minutes. My husband was watching the program, and I was in my office working away on what we do, right? So because I don't have time for TV. But he said, sweetheart, you've got to look at this interview with this Dr. Larry Farwell. And when I went down and I saw your interview, I said, oh my God, I've got to talk to this doctor. I've got to interview. So that's how I knew immediately that I needed to reach out to you, because you and I are committed to finding the truth.
Yes, exactly.
So how does brain fingerprinting get to the truth?
Fingerprinting is a scientific technique for detecting concealed information stored in the brain by measuring brain waves, or EEG. And brain fingerprinting gets to the truth by discovering the truth of what is stored in a person's brain. Now, a perpetrator who has committed a crime knows he's the one who's committed the crime. That information is stored in his brain. What he's done is stored in his brain. And brain fingerprinting detects that information scientifically.
You know how kids want to be a firefighter or a police officer or a teacher? Did you always know you wanted to be a forensic neuroscientist?
From the time I was a little kid that I wanted to be a scientist. My father was a physicist, so I grew up around science and scientists. I figured, okay, if we want to figure what human life is all about, we want to figure what human life is all about, and we want to do that in a scientific way, we've really got to get to the brain. What's human consciousness? What is it scientifically that's going on when we're having all the experiences we have in our life? So I studied neuroscience. I went to Harvard. I graduated from Harvard in studying neuroscience. I went to get my PhD. I got my PhD also in neuroscience and biological psychology. And I started to do research on how the brain works and how that reflects our experience and how the brain reflects consciousness. One of the first things that I did was to develop a brain-computer interface. A kid fell off a silo. He was paralyzed from the eyeballs down. He couldn't move, but we thought he was awake in there. So I thought, well, look, we're getting signals out of the brain from people who aren't talking. They're not moving their hands. Maybe I can develop a brain-computer interface that allow this person to communicate from his brain to a computer using his brain waves. I developed that, I tested it, I tried it out, it worked. We published it in the scientific journals. And now there are probably 1,000 labs around the world that are conducting research based on that original invention. At that time, there was just the one brain-computer interface that I had developed. That first paper we published was called Talking Off the Top of Your Head, because we allowed a paralyzed person to communicate from the brain to a computer to a speech synthesizer. So we could actually talk using his brainwaves. And maybe 1,000 other papers have cited that as people have gone on to refine that technique and build upon what we originally developed. So that's where I got started, in using the brain to discover the truth. And then later I went on to invent brain fingerprinting.
Dr. Farwell, you really changed that young man's life. Thank you for that.
And experience a little bit of what brain fingerprinting is like. One of the photos you're about to see is a president of the United States.
Okay, so let's go through some of these slides. Look at the first slide and the second slide. Next slide. Next slide. And this slide.
And if you go to the next slide, one of those pictures was Donald Trump. And I think that everybody out there recognized Donald Trump. Now, if we were measuring your brain waves if we had a headset on your head that could measure your brainwaves, when you saw Donald Trump's picture, you would have had an aha experience. Your brain would have an aha experience. And we could pick up that pattern in the brainwaves, and we could say, aha, you recognize Donald Trump. That's information that you know. Now, you didn't know those other people, so you didn't have an aha experience when we showed those other slides. Well, we use the same technology to detect whether information is stored in a person's brain about a crime that they may have committed, that they're suspected of, or if they're a terrorist, about a terrorist act that they may have committed. We can show either that they recognize it or they don't, that they know that information or they don't.
So now tell us how brain fingerprinting was used on the Stephen Avery case.
Well, let's look at the fundamentals here. You and I, Janette, are interested in discovering the truth. So where is that truth? Where can we find that truth in the Stephen Avery case? Well, let's say that you and I are sitting in a room here, and we have with us all of the suspects in the murder of Teresa Halbach. So we have Stephen Avery, we have all the other suspects. Now there's one person in the room who's not wondering, gee, I wonder who committed that crime. Right?
Right.
One person knows exactly who committed that crime, and he knows what he did because his brain was there at the crime scene. His brain knows, stored in his brain is the information of what happened at that crime scene. Discovering the truth, it means finding out who in that group of suspects doesn't have that information stored in his brain and who does. So I tested Stephen Avery to see if he had the record of that crime stored in his brain. In getting at the truth, let's look at this case in a little bit more depth. How are we going to get at the truth in the Teresa Halbach murder? Well, one way to get at the truth would be to believe what prosecutor Ken Kratz says happened. If he's telling the truth, then Stephen Avery is simultaneously one of the most brilliant people you can imagine and one of the stupidest. According to what Kratz said, Stephen Avery slit her throat, tied her up to a bed, slit her throat, but didn't kill her, picked her up, moved her still alive into the garage, shot her through the head. And he was so brilliant that he didn't leave a drop of blood in his bedroom or in the garage. But he was so stupid, he left the bullet in the garage. Then he picked her up and carried her out to a burn pit and burned her body just right next to the house. Oh, but before he did that, he picked her up, put her into her car, and took her back out of the car. No apparent reason. Then he burned her body, supposedly. And then he took some of the bones and put them some other place and left the bones right next to his house where they'd obviously be discovered. That's pretty stupid. But he was so smart that he drove her car without leaving a single fingerprint in her car. But he was so stupid that he left dabs of blood, his strategic places in her car, and he even left a little dab of DNA in her car. Now, Kathleen Zellner, Stephen Avery's attorney, hired some of the top forensic scientists in the world in several areas, not just neuroscience, but DNA and fire science and blood spatter evidence to figure out what really did happen at the time that Teresa was first attacked. And according to the forensic science results, what happened when she was initially attacked is that she was behind her car, the cargo door was open, she was hit in the head and blood spattered onto the door. That's the only thing that matches the evidence in terms of forensic science, in terms of the truth of what actually happened. Not what anybody says, but the truth of what actually happened. That was the scenario. Now, even though Stephen Avery heard a lot at the trial, he didn't hear that because nobody knew that at the time. The perpetrator knows that that's what happened. He knows that door was open. He knows that she was down. He hit her repeatedly in the head, and so on. Now, the question is, does Stephen Avery know that information? So I designed a brain fingerprinting test for Stephen Avery in order to test whether the record in his brain matched what actually happened at the scene of the crime. Now, he knew a lot of information from the trial, and we could test and see if he knew that, but that wouldn't help us. What'll help us is to test and see if he actually knows what happened when the crime was actually committed, and take a look at his brainwave responses. And we'll let our audience here be the jury here, and you tell us whether brain fingerprinting shows that Stephen Avery has the record of the crime stored in his brain, or whether he doesn't actually know what happened at the scene of the crime, except what someone's told him. So we presented, you see this first slide here, we presented information about the crime to Stephen Avery. And the first thing you see here is Stephen Avery's brain responses to information that he knows. And this is information that's not incriminating. These are details about the crime that somebody has already told him. And he gets a particular response, which is called a P300 murmur. And that is for memory and encoding related multifaceted electroencephalographic response. You see there's a positive peak followed by a negative peak. And the P stands for positive. The 300 stands for 300 milliseconds, about a third of a second, which is when the response starts. And you can see that distinctive pattern, information he knows. Okay, so that's what his brainwave response looks like when he knows the information. Now mixed in with that, and let's go to the next slide, we presented other information that was irrelevant, things that didn't have anything to do with the crime. Like, for example, if information that he knows was what kind of a car she drove, you get that response because he knows it. Not because he committed the crime, but because people have told him that and he saw her in that car. We could present as an irrelevant thing some other kind of a car that she didn't drive. So you see the green line, it doesn't have that brain response. It doesn't have a P300 murmur because he doesn't recognize it. It's irrelevant information. So now we have Stephen Avery's brain responses to things that he knows and things that he doesn't know. Now, the critical thing, and this is the interesting part about the brain fingerprinting on Stephen Avery, is we showed him information about the crime that he would know, the perpetrator would have to know, because he was there and did it, but that nobody had known at the time of the trial, because it hadn't been discovered yet by the forensic scientists. So let's look at this next slide at Stephen Avery's brain responses to the details about the crime that nobody told him. Does that blue line have a P300 murmur recognition response or not?
No, it's not high like the red one.
Exactly. So you can clearly see science shows, forensic science shows, that Stephen Avery's brain does not contain a record of what actually happened at the time of the crime. He doesn't know that information. And that's what brain fingerprinting showed. Now, you can see that very clearly in this brain response, but we don't make the determination just based on what you and I can see. We go to the next slide, and the computer analyzes the data, and it comes up with a determination, either information present, the record of the crime was stored in Stephen Avery's brain, or information absent, it wasn't stored there. And this determination was information absent, and it computes a statistical confidence. How sure are we that that result is correct? Mathematically, and that was 99.9%. So what forensic science tells us, what brain fingerprinting tells us, is that there's a 99.9% confidence that Stephen Avery's brain does not contain a record of what actually happened at the time that Teresa Halbach was murdered.
Wow, you've managed to take a lot of complicated scientific content and break it down for me and the viewers to really understand what brain fingerprinting is all about. How did you invent brain fingerprinting?
I had invented the brain-computer interface, as we discussed earlier. And I thought, well, what else could we do with the brain? What other truth could we discover from the brain? And I thought, well, we could discover if somebody had the record of a crime stored in their brain, or the record of terrorist activity, or if they were a KGB agent or SVR agent. They would know certain information that they were not going to tell us verbally, but we could detect that because you get a specific brain response, and you saw that with Stephen Avery. You get his brain response, an aha response, when you detect information that you know, when you see something significant that comes up. So I thought, well, okay, we could try that out. I developed the technology, I tested it out, I presented it at a scientific conference, I published it with my colleagues in the major peer-reviewed scientific journals in forensic science, in neuroscience, and also in psychophysiology. And then I presented it at a scientific conference, and the FBI and the CIA were there. They were very interested in what we could do to discover the truth in the brain. And I then started working with the FBI and the CIA and the US Navy to apply brain fingerprinting.
It has a variety of applications.
the brain fingerprinting scientific standards were developed over decades by some of the leading neuroscientists in the world to establish the scientific methods, the scientific procedures that must be followed in order to get accurate results. Obviously, in any science, if you do the science right, you do the math right, you can get very excellent results. I've patented brain fingerprinting here in the US and also in the UK.
How accurate is brain fingerprinting?
Let's look into this in a little bit of detail, because it's a really important question. In science, the truth is discovered by scientific research, where you practice particular methods, you use methodologies that meet the scientific standards, you get the results, you publish them in scientific journals, peer-reviewed scientific journals. So other scientists are looking over your work and passing it, and then it also is passed by the editors of the journals. What matters is the scientific data, the actual facts. Science is about facts, not about opinions. But let's look at what the scientific facts are about it. The original paper that I published on brain fingerprinting with my colleagues has been cited by over 500 other papers in the scientific literature by other scientists. Every single one of those research studies by other scientists acknowledges that the fundamental science behind brain fingerprinting is solid and valid and reliable. The first paper I published on the P300 murmur, the paper about the brain-computer interface, that's been cited by over 1,000 other people, scientists, in the scientific literature, and every one of those has agreed that the science is solid. So when the brain fingerprinting scientific standards are followed, you get extremely high accuracy. Everyone agrees the science is solid, but you may hear different things said about the accuracy. Here, the key is brain fingerprinting scientific standards. All of the questions that can be raised about the accuracy of brain fingerprinting can be answered by 4 words: brain fingerprinting scientific standard. In every single case where the brain fingerprinting scientific standards have been met, I have gotten in my lab, other researchers have gotten, independent researchers have verified, have replicated in their labs. In every case where the brain fingerprinting scientific standards are followed, brain fingerprinting has produced less than 1% error rate. In fact, it's been generally 0% error rate, and high statistical confidence, over 95%. The undisputed scientific facts, and this is with research published in the top scientific journals, conducted at the FBI, the CIA, the US Navy, in actual criminal cases, in counterterrorism cases, and in the laboratory as well as the field. All of the research published in peer-reviewed journals states that when the brain fingerprinting scientific standards are followed, the accuracy is extremely high, over 99%. Error rate is less than 1%. And the statistical confidence is also very high. What the facts say is brain fingerprinting is extremely accurate.
And is brain fingerprinting admissible in court?
Yes, and the reason brain fingerprinting is admissible in court is because the court, in the Terry Harrington case, which we'll talk about later, the court examined all of the evidence that was presented by scientific experts on both sides of the issue who were testifying, and hundreds, if not thousands, of pages of documentation, scientific documentation. And the only possible conclusion was that brain fingerprinting met the legal standard to be admissible. In order to do that, we had to show 4 things: that brain fingerprinting was tested and proven, which it has been, again, FBI, CIA, and US Navy in the laboratory in the field; that it was peer-reviewed and published in the leading scientific journals; that it was accurate, and it had a low error rate. That's the way it's expressed legally, is it had a known and low error rate, which clearly it does, as we've just described, and also that it was well accepted in the scientific community. And the scientific community has a lot of disagreements about everything, but about the fundamental science underlying brain fingerprinting, all the scientists agree, the scientific community agrees, and the judge recognized this, that the science itself is solid. So with those 4 standards met, called the Daubert standards from the US Supreme Court decision in the Daubert case, brain fingerprinting is ruled admissible in court. This took place initially in the Terry Harrington case, which we'll talk about in a few minutes.
Now, you conducted the brain fingerprinting in the Stephen Avery case, so what's next for that case?
The television show came out, The Making a Murderer, which of course is valuable in getting the truth out there. But more importantly, Stephen Avery's attorney, Kathleen Zellner, has been continuing to work to present more and more scientific evidence of Avery's innocence, And that will all be worked out in the courts. There have been several court decisions that have gone one way or the other. There will be more. What's next in that case is that people who are involved in helping to solve that case, such as Stephen Avery's attorney, especially Stephen Avery's attorney, Kathleen Zell, will be bringing up more and more evidence, scientific evidence of what is the truth, and eventually that will come out in court.
Now, your work is done in the Stephen Avery case. What other cases have you applied brain fingerprinting?
Terry Harrington, an innocent convict who was freed after 23 years of a life sentence for murder. There I am conducting a brain fingerprinting test on Terry Harrington. You can see in the background the guards. This is done in the prison where he'd been for 23 years at the time. Terry Harrington was convicted of murder. He was convicted of murdering a retired police captain who was serving as a security guard. People testified against him. There was some evidence that went against him, and the jury made the decision that he was guilty of the murder.
How did you get involved in the case, Dr. Farwell?
I got involved in the case because someone believed in Terry Harrington's innocence and contacted me and asked me if I could conduct a brain fingerprinting test. And Terry Harrington, I talked to him on the phone. He said, I'm innocent. I'll do anything to prove it. So I said, all right, we'll conduct a brain fingerprinting test. And if you look at the brainwaves here, again, let's let the audience decide what they think about Terry Harrington. There's Terry Harrington's brain response to the things he knows. Again, you see that positive followed by a negative. The line goes up and then it goes down. That's the electrical brain response to things he knows. Now, these are not incriminating things. These are just details that he knows. Then let's look, next slide. Irrelevant information, you don't get that P300 murmur response, the green line, basically a flat line. Now, the question is, did Terry Harrington recognize the details about the murder that no one had ever told him, but the perpetrator must know? So take a look at the next slide, blue line. What do you think?
Wow, that blue line is very close to the irrelevant green line.
Exactly. He doesn't show that recognition response to these details about the murder. Now this, like the Avery case, this was difficult because he knew a lot of things about the murder from going through the trial, and it wouldn't help us to show he knew what he learned at the trial. But this showed that the things he hadn't been told at the trial, he didn't know. If we go to the next slide, we analyze the data, and you see information absent, 99.9% statistical confidence. Brain fingerprinting was ruled admissible as scientific evidence in court. You see me there testifying in that little picture. You see me testifying about his brainwaves. And he was released from prison based on a constitutional rights violation based in the initial trial.
That is amazing. That's what Stephen Avery is hoping for.
That is what Stephen Avery is hoping for, exactly. And he's going to use perhaps some of the same evidence. I went back and confronted the man who had testified against Terry Harrington and said he was a witness to the murder, said he'd seen Harrington commit the murder. And at first he said, well, yeah, I was there. I heard the shotgun blast. I saw him. He had the shotgun. He killed him, et cetera, et cetera, et cetera. And I kept saying, well, look, you may say that, but Harrington's brain says he wasn't there and he doesn't know about it. Finally, this young man said, okay, I made it all up. Kevin Hughes was accused of the murder himself. He was 17 years old. It was Pottawatomie County, Iowa. He was black. They said, if you don't give us somebody else, we're going to send you up for that murder. So he made up the story, and the police filled him in on details so that he'd make up a story that matched the evidence. And he lied at the trial. So that came out as evidence also later on. And Terry Harrington sued the state of Iowa, and he won for $12 million for falsely convicting.
Justice was served in the end.
Justice was served. And we're hoping justice will be served in the end, even though it sometimes takes a long time. We're hoping justice will be served in the Stephen Avery case.
What about J.B. Grinder?
Okay, J.B. Grinder. Well, we sort of, there's a bit of a spoiler here. We've said he's a serial killer, but at the time I was running the test, we didn't know if he was a serial killer or not. Let's look at his brainwaves. Okay, there again, the scale's a little bit different, but you still see the P300 murmur, positive followed by a negative voltage at the scalp. For the things he recognizes, these are things that are not incriminating, but details that he knows. He gets that brain response. So he's okay. We know his brain is responding. He's getting the brain response we expect to things he knows. Go to the next slide. He doesn't get that brain response to the irrelevant things, the green line. Now let's see what his response looks like to what we call the probes, the details about the crime. What do you see there, Janette?
I see the probe stimuli is very close to the shape of the red target stimuli and not
Exactly.
following the irrelevant wave.
Exactly. Let's go to the next slide and see if the computer agrees with you.
What does the grinder data tell us, doctor?
The determination was information present. The statistical confidence was 99.9%. So J.B. Grinder, he had literally gotten away with murder for 15 years. This murder was 15 years before. And this showed that the record stored in his brain matched the crime scene, that he knew details about the crime that nobody other than the perpetrator and investigators knew. So at that point, he knew he was going to be convicted and he would probably be getting the death sentence. So he pled guilty in exchange for life in prison, and he confessed to the murders of 3 other young women. First of all, Janette, I like to distinguish between what we can say as a forensic scientist and the whole truth of the matter. As a forensic scientist, what I can say is that in the 3 cases, we tested 3 different brains for the record of the crime stored in that brain. In the case of J.B. Grinder, the record of the crime was clearly stored in that brain. He confessed, he was guilty, he went to prison. In the case of Terry Harrington, the record of the crime was not stored in his brain. His record matched the alibi. What was stored in his brain didn't match the crime scene, and he was ultimately released. In the Stephen Avery case, we got the same result as with Terry Harrington. The record stored in his brain didn't match the crime scene. He didn't have the details of what actually happened at the crime stored in his brain. Now, as a forensic scientist, what I can say is the record stored in his brain didn't match the crime scene. He didn't know the details about what happened at the crime. Now, with respect to innocent versus guilty, that's not a scientific determination, that's a legal determination, and that's made by the judge and jury. So when I testify in these cases, I don't say, there's your murderer. I say, this record is stored in the brain or this record is not stored in the brain. Just like DNA. The DNA scientist doesn't say, okay, that guy's a murderer. He says the DNA at the crime scene matches the DNA that was found on the suspect. And then the jury makes that decision as to innocent or guilty. So in the Harrington case and the Avery case, the making murder case, brain fingerprinting provided powerful evidence that the suspect was innocent. In the J.B. Grinder case, brain fingerprinting provided powerful evidence that the suspect was guilty.
Dr. Farwell, in your life and in your professional work, what's your driving force?
Well, Janette, all my life I've been interested in discovering the truth, just like you. And brain fingerprinting has been one avenue for discovering the truth for me. It continues to be an avenue for discovering the truth. Most of the work that I'm doing today is classified counterterrorism work overseas. I spend a lot of time in the Middle East, other places overseas that are in need of counterterrorism work, in need of discovering the truth, because we can find out the truth of who's the mastermind behind hijacking, who is the mastermind behind a mass shooting, who's the mastermind behind a suicide bombing. Usually the end perpetrators are dead at the end of those kind of operations. But the masterminds are there and they have the records stored in their brain. So I've put together brain fingerprinting tests to detect the masterminds behind major terrorist incidents, major terrorist crimes. And that's one of the major things I'm doing now, which I can't talk about because all that stuff is classified. I'm also interested, just as you are, Janette, I've been interested in discovering the truth all my life. I'm also interested in discovering the truth about things that matter to us as human beings. I've been working on consciousness and how we can use our consciousness, how we can use our brain to create the life that we want. We've conducted research. I've conducted research in collaboration with my father, a physics professor, Dr. George Farwell. I've conducted research with him on how your consciousness can actually have an impact on the physical world, down to the subatomic particle level, down to the quantum mechanical level. You can actually change what's happening out there in the physical world just by the intention on the level of your consciousness. So all the people who are saying, hey, in order to be successful, you have to have first an inner vision and then nature will help you to carry that out. Well, we provide scientific evidence for that. And I've developed techniques to use your brain in an effective way to create the life you want. I've come out with one book about this. I'll be coming out shortly with another book about this, about how discovering the truth on the level of your consciousness, on the level of how your brain works, can be practically applied in practical techniques for living the life of your dreams. And that's something that in a way goes beyond my previous discoveries. It's something that's fascinated me and I've been working on for some time, I've come up with some scientific results that actually I think can make a difference. My first book is called How Consciousness Commands Matter, the New Scientific Revolution and the Evidence That Anything is Possible. And it goes through neuroscience, the new modern discoveries in neuroscience, modern discoveries in physics, relativity, quantum physics, and how they show that consciousness has a commanding role in the universe. And then research that my father and I did, he did the physics end, I did the neuroscience end, that shows that we can actually influence the probability distribution of quantum mechanical events using consciousness alone. And what I mean by influence the probability distribution of quantum mechanical events, what I mean is make things happen in the real world, because the real world is all constructed out of quantum mechanical events. So we showed scientifically, but all of these wise people from thousands of years ago in all of the foundational scriptures of all the religions and the spiritual practices, and whatever book came out last week about how to be successful. All these people who say have this inner vision on the level of your consciousness and nature will collaborate with you to carry it out, they're right, and we showed that scientifically. And then I talked about how that integrates with all of the science that's been discovered by others in the scientific world. That book laid the foundation. My new book, which will be coming out within a few months, will be, okay, how do you apply that knowledge to create the life that you desire? My new book is going to be titled The Science of Creating Miracles, Neuroscience, Quantum Physics, and Living the Life of Your Dreams. And that will be applying all of this science in daily life, in things that our viewers can use to enhance their own life.
Your neuroscience research, discoveries, and brain fingerprinting invention offer greater opportunities to reveal the truth. Dr. Farwell, how can people get in touch with you?
They can reach me at my website, larryfarwell.com, and that website contains much more detail than we've gone into here today about the cases and about brain fingerprinting and about my other research and so on. They can email me at brainwave@larryfarwell.com. And my telephone number is there on the screen as well.
That's wonderful. So we've learned a lot, and I loved how you were able to take very complicated neuroscience, forensic neuroscience, into these slides that everybody can understand. And tell us again what those red, blue, and green lines mean.
Okay. The red line is information that the person knows. We know he knows it. It's non-incriminating information to get a brain response that shows what the person knows, what the brain response is when he knows the information. The green line is irrelevant information. You don't get that brain response, the peak that goes up and then the peak that goes down. You don't see that to the green line. It's irrelevant. Now, the blue line shows the brain response to the details about the crime that no one has ever told him, that the perpetrator would know and investigators would know, but nobody else knows. And in this case, the one you're seeing right there, that's J.B. Grinder's brain response, and he knows the details about the crime, as you can clearly see. The blue line matches the red line.
Dr. Farwell, what is your core interest?
I think you and I are similar, Janette. I'm interested in discovering the truth. And I'm interested in discovering the truth from the point of experience and from the point of being able to prove it scientifically. And there are different ways you can apply this. You can apply discovering the truth to solve criminal cases, put bad guys in prison, put criminals and terrorists in prison, free innocent people. You can discover the truth in ways that have to do with, well, how can you apply your consciousness? How can you apply your brain to create the kind of life that you really desire? And in all of everything that I've done, I attempt to discover the truth and then to prove it scientifically.
This has been a fascinating interview, and we look forward to reading more about your work. We'll follow you as you work on forensic cases, and we look forward to your upcoming book.
Thank you very much.
And you'll let us know when that next book comes out, right, Doctor?
Yes, I'll do that. That was excellent. Really, I meant what I just said a minute ago. I've had hundreds of interviews, and you've done a really excellent job. So I really appreciate it. Thank you.